The last section of this unit is going to be working with cubed roots, which is going to be taking a lot of the stuff we've been doing and just kind of extending it a little bit, but it should be very similar to square roots. So, perfect cubes is the same idea as perfect squares. So if you have 2 cubed is equal to 8, then the cubed root of 8 is equal to 2. If 3 cubed is 27, then the cubed root of 27 is equal to 3, and so on all the way down. If you create this list all the way down to 10 and bring it to class tomorrow, it's worth a piece of candy. So here are a couple examples of what we're working with. So I have the cubed root of 0. Well, 0 cubed is equal to 0. Therefore, this answer is 0. The cubed root of 125. Well, 5 cubed is equal to 125. Therefore, the cubed root of 125 is 5. 216, same idea. 6 cubed is 216. Therefore, the cubed root of 216 is 6. Now, 729, this gets a little bit trickier. Now, you could look to your cubed root list. That would be fine. I'm going to try to work this one out by hand and try to think through it logically. Well, I know that 10 cubed is 1,000, so it's got to be less than that. I could try 9 cubed, which is 81 times 3, or not 3, 81 times 9, and that's 972, and there it is. So 9 cubed is equal to 729, therefore this is equal to 9. And the way that I try to think through this is I'll take that 9 squared, that's 81 here, and I'll take that times 9 and I'll look at the last digit. I know that 1 times 9 is 9 right there. Therefore, this is a possibility. It wouldn't work, let's say, for 7 cubed, because that's 49 times 7. So the last digit would be a 3, and therefore that one probably wouldn't work. So I look at that last digit and I just try to use some critical thinking. Now, that's obviously not required, but it would make your job a little bit easier. Now, for estimating cubed roots, we do it exactly like we did for estimating square roots. We got to find 2 on each side and work from there. Now, I know that the cubed root of 27 is 3. And so that's really close. And I know that the cubed root of 64 is 4. Whoops, I better write the cubed up here so I'm not way incorrect. So that means that this has to be between 3 and 4, just like we did before. It's closer to this side, so I'd say 3.2 or 3.1, something like that. Now, for this one, I can kind of cheat since I just did the cubed root of 729, and that was 9. So now I have to do the cubed root of whatever 8 cubed is. So that's going to be 64 times 8. So that's 32, 51, so 512. Is that right? Yeah, 512. And then it's closer to this side. Therefore, I would say it's going to be like 8.8 or 8.9, something like that. Okay? So same idea as we have been doing before. You got to sandwich them between 2 perfect cubes and then go from there. Try these 2 on your own and see how they go. So cubed root of 425. So let me check what 7 cubed is. So that's going to be 49 times 7. That's 28. So 343. That seems pretty close. Is 7. And I just did 8 cubed, which is 512. Whoa, that's not good. There we go. So that's 8. This looks to be pretty similar between them, so I'm going to go 7.8. 5. But once again, it's an estimation, so you can be a little bit off. That's fine. Cubed root of 150, well, I know that the cubed root of 125 is equal to 5. So this has to be 6. So that'd be 36 times 6, 216. And that works just fine. It looks to be a little bit closer to this side, so I'm going to say 5.3, somewhere in that range. Okay? So very similar to square roots, except that the numbers get a little bit bigger, and you got to think a little bit more, but you should be just fine. After this, there is a quiz, and then a test over the entire unit.